Hello everyone, I'm Abhishek Maurya and I'm going to present the work in the research paper titled OBTracker, Visual Analytics of Off-Ball Movements in Basketball. The basketball game is very famous all around the globe. The image in the current slide, we can see a basketball game where a person marked in a red is trying to score a ball in the basket, and he is very important for the team and the team's win. Now the person of the same team who doesn't have a ball creates movement, and those movements are called off-ball movements, and these movements are also very important for creating opportunities for themselves as well as their teammates. For example, a person doesn't have a ball can run in a different direction and can distract the defender of other team such that the player who has a ball of the same team gets a free zone to score, and hence off movement is very important in the game. Now if you want to analyze how off ball movement is working, it is very difficult to analyze by looking at the score or other basic statistics. Hence we need a better visual system to analyze the off-ball movement that consider both spatial and temporal aspect of the game. Spatial aspect of off-ball movement is basically referring to a off-ball movement by a person relative to a other person in terms of distance as well as angle. Temporal aspect of a off-ball movement basically refers to the time of a off-ball movement that helps in scoring. The goal of a paper is hence basically to develop a visual analytical system which analyzes off-ball movements of a player, considering both spatial and temporal aspect of it, and hence it helps the coaches of a game or analyst of a game or other users of a game to better understand and assess the off-ball movements and how it is helping the game. The visual analytics system given in the paper is called OBTracker, which we can see in an image in the right side of the current slide, which basically shows all the off-ball movements, and hence it analyzes the different aspect of off-ball movements. So as the implementation of a OBTracker, the first step was the author collaborated with basketball experts to understand their need and requirements considering off movement of in basketball game. This helped them to identify the key features that OBTracker should have. The major three key features were, first of all, team view. Considering the past data, play data of any particular team, OBTracker should be able to have take out most common and effective off-ball movement patterns. Second was player view. Again, using previous data, OBTracker should be able to get uh, different types of ball movement that an individual player are performing in. Third is OBTracker should have an interpretive model which basically have a good understanding and explanation of the effectiveness of any ball movement followed by any team. So basically this is the proposed OBTracker system overview. It has three major components: storage component, modeling component, visualization component. In the storage component, data set is stored, which is sports view data set, and it has previous NBA games data. The major information is list of possession of a ball by each player of each team and the off ball movements of each player in each team. So this data is stored in the storage component, and then this data is used in a modeling part, which is a machine learning interpretable model which performs two tasks. One is assessment, where it checks which off ball movement is helpful for the team or contributing in offensive attacks, and the second task is aggregation. Basically it tells which off ball movement is typically used and is effective by any team. Now the third component is visualization. The output of a machine learning model is visualized using different visualization methods we have studied in the class, and it generates team view, player view, and an action view. And we will be looking into the model and visualization components in further slides. Now, as a next step, author develops a new interpretable model for assessing the effectiveness of an off-board movement. Now, what does assessing effectiveness of an off-ball movement means. So suppose a off-ball movement is done by a player who doesn't have a ball, then if does that movement result in that player getting a pass or a getting a ball? So it basically tells the effectiveness of that movement. Hence, this problem boils down to whether the off-ball movement will result in pass or not. Hence, the linear regression model is trained with input features or input parameters and an output variable which is a 0 and 1, which is whether a person would get a pass or not. Some of the input parameters are passing distance, which is basically distance between the person who has a ball and the person who did the off ball movement, like in this example. Second is number of defendant near the passing path. So if this is the ball and this is the player who did off ball movement, then how many number of defenders are there? So, and other factors are average distance from defender to the pass path and minimum distance from defender to the pass path. Now, using all these features, the probability is calculated whether the person who did the off ball movement would get a pass or a not. The data set is basically divided into two parts, 50% for training and 50% for testing. Now, as a next step, author validates the model, performs the validation of the model, and performs the evaluation of the model. In validation of a model, the trained regression model is tested with a prediction task, which is whether the person doing the off ball movement will receive the pass or not. Now, the result is tested if the result comes under top 1 or top 2 or top 3 results. Now, according to the final result, the number of output which comes mostly under top 3 result, which is 96.7%, which suggests that the model can accurately predict the passing probability of off-ball players. Now, the model were evaluated to predict if the possessions is likely to score or not. From the result, it can be seen that the top 5% of a possessions can have a good actual scores, which means the model is able to accurately predict which possessions are more likely to result in a score and hence having a good score for a team winning, which is a result of good effective off ball movement. This is the third and most important component of OBTracker, which is visualization. Now there are three visualization views. First is summary view, which is basically team-wise glide design showing the off-ball movement path here. Now the summary view is valuable tool for coaches and analysts who want to understand the off-ball movement pattern of a particular team. It basically provides a quick, easy way to identify teams' most common and effective ball movement. Second is a table view. Basically, it's a player view, table view, where it shows a combination of player as a rows and in a column it shows performance indicator. Now, a player view of a OB tracker system is a visualization that provides the detailed information about the player who execute a type of ball movement. It is basically help to design coach and analyst to identify which player combination to use for a different type of off-ball movement. The third is explanation view, which shows the player and ball position at the specific time using a Voronoi diagram here. Now, this view of a OB tracker is basically provided, uh, it provides the explanation of a particular ball, off-ball movement and designed to help coach and analyst basically to understand how off-ball movement was executed and how effective it was. The main conclusion of the paper is that the author has developed an effective interactive visualization system for off-ball movement analysis in basketball, which is helpful for the coaches and analysts who analyze the off-ball movements. Unique contribution by the author was firstly to provide a comprehensive framework with a machine learning model to provide a complete solution for off-ball movement analysis in basketball. Secondly, to provide an interactive visualization framework for coaches, analysts, or other users to perform off-ball movement analysis. Now, the possible future work can be to investigate the relationship between the off-ball movement and the actual performance of the team. The second future work can be adding a speed factor in the off-ball movement analysis so that it can be judged based on the team performance. So the references are taken from the paper, and any other references are linked in the figures and tables in the slides. Thank you. Any queries are welcome in this email.